is cross-price elasticity of demand. So cross-price elasticity of demand is a measure of the responsiveness of quantity of one commodity demanded to changes in the price of another commodity. So again, it is very similar to our price elasticity of demand, where we focused a little bit more of the energy, which was simply our percentage change and quantity demanded over a percentage change and price. But in this specific case that we had here, this could have been the percentage change in quantity demand of good X for the price of good X, a certain change in the price of good X. The difference here is that you have a percentage change in quantity demanded for good X based on a change in price of another good. Otherwise, the formula is the same, calculation is exactly the same. So I would like you to take a second here, pause the video, and try to calculate out what would be the percentage change in cross price, what would be the cross price elasticity of demand by calculating percentage change in quantity demanded, percentage change in price. And once again, make sure you go in the same direction from one to the other, whether we call it original and new or just point A and point B or whatever. You want to go in the same direction because the actual sign of this cross price elasticity of demand, whether it's positive, whether it's negative, whether it's equal to zero, will have a big impact. So take a second. All right, so if through this calculation you have found a cross price elasticity demand of 0.6, you are right. And 0.6, what can this tell us? Well, first off, in this case here, it's positive. So as I mentioned, positive or negative has an impact. Positive tells us what? Well, we know that as the price of a certain good goes up, the quantity demanded of that good falls based on the law of demand. If that price of the good goes up and the quantity demanded for the alternating or the other product goes down or up, will tell us if it's a substitute or a complement. So we have two different possibilities. The price goes up of a good, quantity demanded of that good goes up, of the other good goes up. Therefore, we're dealing with substitutes because as the price of this good has gone up, we know that by the law of demand, the quantity demanded has fallen. But if a lot of people substituted away and went to the other product, and this other product now sees a greater amount of sales, it's because we're dealing with substitutes. However, if as the price goes up and we demand less of good B, we now demand less of good A as well. Well, in that situation in there, we could see that actually as we demand less of a good, we're not demanding more of the other, we're demanding less because they are typically consumed together and they are known as complements. So once again, if we look along the spectrum here from positive infinity to negative infinity, with zero in between. If it's positive, we're dealing with substitutes. If it's negative, we're dealing with complements. And if it's equal to zero, we would say that these goods are unrelated. Okay? They are not related to one another at all. And also, if I look at this, if I'm close to zero or I'm further away, or I'm close to negative and this portion here are further away, the further away I am, the more I am related. So a higher degree of substitutability between Shell gas and Petro-Canada gas than if we were to compare Pepsi and Coca-Cola. Some people might still have a preference. Or if we might compare Rossignol skis to Dynafit or another brand, or if we were to compare a Toyota to a Honda or something else, well, if they're not completely substitutes, they might be more unrelated, but if they have a high degree of substitutability, they're more likely to have a very high number between them.